Hi everybody, welcome to another video in Linear Algebra, section 6.6, Application to Linear Models. This way line. So you will see this in a lot of different class like statistics, for example, physics. So point being is we have a lot of points and we try to find the best line, the best fit line, or in this case we call the least square line or regression line, the line that best fit to all the points. Of course we have a bunch of points and the line only 2 points are needed to define a line, so we have too many points. So in that case there's most likely there's no solution. So in that case we just find the best fit solution, right? So we have a bunch of points here. So the best fit line, this is the line that won't be like this, and the objective is to find the equation of that line, right? Of course the calculator have that application, but just want to explain that using what we learned from the previous section. That will be very simple, right? So it says that to compute the least square solution here, where we solve that and we find the solution in this form, and the least square line is y equal to beta naught plus beta 1 x. I forgot a naught here, right? So that's how we set it up. So the matrix X, we're going to have 1 and then x1 x2 of course will come from the point, and y1 y2 will come from the point here, right? So let's look at the first example. The math itself in this section is simple, but I just want to show you a lot of things that we can use in the calculator. Right. First we have the points here, of course, x1 y1 x2 y2 x3 y3 and x4 y4. So let's set up the matrix X. There are 4 points, so 1 x1, 1 and x2, 1 and x3, 1 and x4, which will be 1, x1 is 2, x2 is 5, x3 is 7, and x4 is 8, right? And then y, the vector of all the y values, y1, y2, y3, y4, one, 2, 3, and 3. Right. I just solve the equation first. So we solve the equation X. This is just the matrix X. Sorry. X times the vector beta equal to vector y. Equivalently, we will solve the normal equation x transpose x beta vector equal to x transpose y. And if once again the vectors, the columns of x are linearly independent because they are not multiple of each other, we know that x transpose x is going to be invertible, and we can just use the pseudo inverse. But let's just write four row, 2 column, 1 and 2, 1 and 5, 1 and 7, 1 and 8. Right. Just hit enter. So that is the matrix X. What we need is x transpose x. So we have 24, 22, 22, 142. Beta is beta naught, beta 1, y. That means x transpose y, x transpose y. Nine and 57. Just solve this system of equation. The most efficient way, of course, reduce row echelon form. So we have the equation b naught equal 2 over 7, and just write the reduced row echelon form first. So beta naught is 2 over 7 and beta 1 is 5 over 14. So the least square line y equal to beta naught plus beta 1x, or we say y equal to 2 over 7 plus 5 over 14x. Right, so the math is very simple. And now let's try to make sense of it. We have the point 2 and 1. X equal to 2, y equal to 1. X equal to 5, y equal to 2. And x equal to 7, y equal to 3. X equal to 8, y equal to 3. Of course, we try to find a line that best fit of those points. It's not going to work out perfectly, but it will be something like this if we have to guess. Right. So the rule that I learned from the other class, when try the best fit line, if there's a bunch of points, make sure that you have above the number of points above and the number of points below are relatively the same. So try to make the best fit line show something like this. Just guess. And then the equation of that line will be y equal to 2 over 7, 5 over 14x. Right. Of course, if we want to use the calculator, there's an option for that. It's that, and then edit. So enter the list first. The point is 2 and 1, 5 and 2, 7 and 3, and then 8 and 3. Right. Once again, second stat. This is stat and edit, and then we calculate linear regression ax plus b, or linear regression a plus b. Let's go with this one. Okay, so we have list 1, list 2. That's good enough. And let's just store the equation into y1. Okay, variable y variable function y1. Right. So once again, I just calculate first. First that, and of course we have here 2 over 7 is that, and 4 over 15 is 5 over 14, sorry. Right. And now let's do that again, and of course we have the equation which is the same as what we have. Right, so that's good. Now if we want to plot this, by the way, I don't recommend you do this in this class, because if we want to plot a second equal sign stat plot and hit enter, is turn it on. That's it. When we hit y equal to, as you see, when we do the regression, it stores the equation, so we do have equation. But most importantly, you see here on the plot, it is highlighted. On other circumstances, make sure none of those highlighted, because otherwise it will do something strange. But if we hit the graph, first we have the point, and then we have the best fit line, as you see. Yes, it turned out to be very nice. However, like I said, if we're not using it, make sure we have to turn off the stat plot, otherwise it will not work in normally. So yeah, that should not be highlighted. If you don't plot the points, that should not be highlighted. Right. And to turn it on, turn it off, hit second stat plot and then hit enter, then we can turn it back on. Right. I always recommend that if we don't plot the point, keep that off. Right, so we have the equation. Right, so actually there's more to it, why the setup here works. Right, in that case, actually just multiply it out. You will see exactly what we mean by that. Right. Now if I multiply x b equal to y. Now let's look at the equation xb equal to y. I'm just going to write in terms of x1 and times beta naught, beta 1, y1, y2, y3, y4, right? That's the equation, right? Now let's multiply this out and see what we get. 1, so we have b naught, beta naught, plus beta 1 x1 equal to y1. Well, that's just the equation of the line, right? And then beta naught plus beta 1 x2 y2. Not the equation of the line. Beta naught plus beta 1 x3 equal to y. Yeah, I've just rewrite this vector, this matrix equation into system equation. Beta naught plus beta 1 x4 equal to y4. As you see, we just have a bunch of linear equation, and what we're trying to find here is the beta naught and beta 1, so that the solution as close as y as possible. So that makes sense, right? So if we want the best fit line, that's beta naught and beta 1, and multiply it in this way. That's why we can set it up like that. Now let's say if we want, instead of the best fit line, we want the best fit curve, let's say quadratic. In that case, we'll just add one more, x1 square 1 x2 square 1 x3 square, and so on. And here we have beta naught, beta 1, beta 2 equal to, because y1, y2, y3, and so on. Now let's multiply it out. When we multiply this out, we have beta naught plus beta 1 x1 beta 2 x1 square equal to y1. So you see we have the quadratic equation, and we're trying to find b, beta naught, beta 1, and beta 2. so that the left hand side as close as the right hand side for all the points as possible. So that's why the least square work, right? So that's why when we set this up, we try to find beta naught and beta 1 so that the x times beta as close as to y as possible. And the solution is beta hat. Yeah, forgot the hat here. But in terms of least square, the solution is pretty simple. The setup x and then y. Of course, if we want the quadratic, just put x1 square. If we want cubic, x1 cube. So simple enough. Next, find the equation y cube beta forgetting beta naught and beta 1 of the least square line that best fit the points. So once again, we just set up x 1 x1, 1 x2, 1 x3, 1 x4, 1 1, 1 2, 1 4, 1 5, and y will be on the y values. Zero, 1, 2, and 3. Right. So we have the equation x beta equal to y, or for the normal equation x transpose x beta equal to x transpose beta y. And notice that in this case, once again, x, we have two columns. They are not multiple with each other, so linearly independent. So we can just use the pseudo inverse. Forgot the hat again. So beta hat equal to x transpose x of that inverse x transpose times y. That gives us the solution. Right. So just enter the matrix X. Two rows, 4 columns. Four row, 2 column. Of course, when that happens, I just enter the matrix and then I transpose, but I don't want to do that. So 1, 2, up 1, 1, 1 and 2, 1 and 4, 1 and 5. Right. And then we just enter that. A transpose A, that inverse A transpose, and then times y. Zero, 1, 2, 3. Negative 0.6, 0.7. So the equation is y equal to beta naught plus beta 1x, or we write y equal to negative 0.6 plus 0.7 times x. Right. Let's just plot the point. X equal to 1, y equal to 0, x equal to 2, y equal to 1, x equal to 4, y equal to 2, and x equal to 5, y equal to 3. Okay, best fit line. Now if we use the calculator, again, hit stat, and then the stat, and then edit. Now if you want to clear the list, do not hit the delete button here. Never do that. Just highlight the list, hit clear, and then enter. That will clear the list. Don't hit delete. If you accidentally hit delete, it will disappear. In that case, have to just delete the whole thing. And then we can hit second 2. That clear. Right. And then just go here and then we name it again, second 3 for L3. Just don't delete it, just clear the list. Right. And then enter 1, 2, 4, 5. And then 0, 1, 2, 3, 2, 3. Right. And then stat and calculate. I will use just this one. If we want to do the equation, let's store that into variable, y variable function, store y1. Right. And then just go down and calculate. Right. Of course, we have the same equation. Right. Once again, to clear the list, hit stat, edit, highlight the list, clear, enter, clear, enter. Right. So we have the equation. That's simple enough. Once again, the idea behind is we try to make all of those equations as, if it's not equal, as close together as possible, because we have too many equations with only 2 variables here. So most likely we have no solution, but we try to find a solution that all of those equations will be as close together as possible. Of course, we can extend that into quadratic and cubic and so on. The idea is still the same. But that's all I want to cover in this section. Thank you for watching, and see you in another video in linear algebra.